Good. Today I would like to explain the engineering drawing, the unit called isometric projection. This unit for you are having as fifth unit. I am writing here, just see all of you, unit 5. The title is Isometric Projections. So what isometric projection is? You need to understand. Something like iso, I am using the word. You are studying about isotopes. You know what is isotopes is? So, which is having same atomic number and different mass number. Like that, if you see isotones, likewise. Iso always represents the equal or same. So here what is iso? What is the equal here? That I will like to explain by taking one kind of cube here. So I will show the cube. I will see the cube how it is there. It is having 6 sides. One side, second side, third side and fourth side. And upper side and bottom. Totally 6 sides are there. And all 6 are, just see, all are equal. That is what cube is. But when you are drawing in orthographic way, I would like to explain orthographic. Let us say I am writing that cube in orthographic way. Just see what is this. So when you are seeing this cube from front, when you are seeing this front, this one, how we are going to write it? We are having some idea about orthographic projections. First of all, we have to write XY line. Then front view you have to write. When you are seeing from front, how it is visible? As a rectangle, that is as a square that is visible. This is a square that is visible. So whatever the dimension may be. I am saying a small cube, here let us say 30 mm dimension, here also 30, here also 30, here also 30, like that. It is front, when you are seeing from front. Let us say we are seeing from top, how it is visible. When you are seeing from top, it is visible like as, once again one more square here. It is front view, it is called top view. But what about side view? Side view, either we can use left hand side or right hand side. No problem, we can use both sometimes. At least one we can write, because in cube it is symmetrical, either side, left side and right side. I am taking left side, we have to draw right side of the front view. So this is once again one more square of dimension, same 30, because it is square, no? Cube means all 6 sides are equal. It is also 30, 30, like that. Here also it is 30, 30, like that. Right? This is front view, top view, it is side view. Even here we are saying it is left hand side view. No problem, left hand. If you wanted to write right hand side view, we have to write right side of this front view, we have to do it this side. So no problem. This is how we are going to do it. This is cube actually. Cube, okay, you can understand a little bit by seeing this front view, top view, side view, seems to be it is cube. Let us say some kind of rectangular object, cuboid, or some other ways from cones, some other different kind of solids. Can you imagine that it is a cube? We can't. Unless we are having some kind of drawing knowledge, we can say it is a cube. Only when we are having the knowledge of this, then only we can say it is a cube. Otherwise, we are unable to say it is a cube. So, the other way of projection is, what we are discussing is isometric projection. This is orthographic projection. That's why we are learning isometric projection. This one, how we have to do it? This one we have to do it like as you see here. I am writing here isometric cube. It is XY line. So one side we have to take on 30-degree line. Other side we have to take on 30-degree line. So here we are going to have 30 on 30-degree line, because the side we are taking on 30-degree line, other side we are taking 30-degree line, this length also 30. So the vertical only we have to take it like this. See, we are getting 3 directions. Let us say we can write 0 to x direction, then 0 to y direction, 0 to z direction. So with 3 axes we can try to write the cube. See here, we are going to write, it is 30, okay, vertical. Same 30 which is parallel to this line, from this point we have to write it by keeping your mini drafter here and draw here. Like as this. What is this length? Same thing, whatever the 30 is there, same 30 take here. So it is 30. Here also take the extension line for this, parallel to this line. Keep your mini drafter here and keep over here. Draw the line. This length is also 30, like this. Now draw the parallel line for this line. Keep your mini drafter here. Keep over here. Draw the line which is parallel to this. So it is also 30. Because this length only, same thing we are getting. Here also draw the parallel line for this line. From here, draw the line. Right? Now, from here, draw the parallel line for this line. For this line, draw the parallel line. Keep your mini drafter here. Keep over here. Like this, it is coming over here. Draw the line. This length is also equivalent to this length. No problem. 30 only we are getting. It is 30 only we are getting. From here, we know this point and this point. Draw these lines. Just see. So, you just see this object. Once again, I am making dark. This is looking as cube. All 6 sides are equal. So we know this is one side, second side, right? Third side, which will be their back side here. Actually, this is the back side we are getting. Fourth side, then fifth and bottom sixth side. So when you are representing like this, we can understand it is a cube. We can say it is a cube. Let us say we are seeing from this side. I am writing the arrow. That means we are focusing from this side. So this square is visible like as this. This top view is visible like as this. This side view is visible like as this. This kind of projection is called isometric projection. Isometric, actually isometric projection. See, the advantage of isometric projection is the cube is represented like this. The same cube also represented like this. You just see, an ordinary person also able to understand this, it is a cube. But this they are unable to understand because unless they are having drawing knowledge, they are unable to identify it is a cube. But here they can identify. That's why it is making use the difference as compared to this. So how we have to draw it? Why we have to take like this? I would like to explain little bit further. So here what I would like to say is, we know if you are seeing the cube, see here, this is 30 degree, no? Actually see what is the angle between two lines here. See here, this is the line, this is one more line. The angle here is 90 degrees. The angle between this plane and this plane is also 90 degrees. Just come over here. Actually, just see, the angle between these two is 90 degrees. Actually, this angle is 90 degrees, but it is not 90 degrees here when we are writing in isometric projection. Here, how much we are writing? As we are taking 30 degrees, we are drawing all parallel lines. We are getting 30 degree line over here. This is also 30. But what it should be? Here we are getting only 60 degrees, but we are missing 90 degrees. 60 only we are getting. That 90 I am doing small kind of analysis. See here, I am drawing actually this half line is 45 degrees. When it is entire angle is 90 degrees, the half itself 45. So I am writing little bit extension like this. See here, this line I am writing here. This angle I am saying, how much am I? Tell me. 45, because I am taking true angle. Here also we can take 45 degree. Here also it is 45 degree. Just here I am writing. I am extending the line like this till the middle point. Just you understand this. This is the 45 degree line. Actually we can say it is a true line. true length or otherwise. It is called isometric length. Now I am magnifying this entire diagram aside. See here, this horizontal line I am writing here. Let us say it is O point. This is O I am writing. Forget about the distance. You just have that. Now I am writing 30-degree line. This 30-degree line I am writing. How much distance we have to take? 30 mm we are taking, for example. 30 mm we are taking. Then we are taking one more line which is real or true line, making 45-degree line like this. This is 45-degree line. This all I am doing to make some kind of analysis. See here. Now I am drawing the line as I am showing here. This point I am marking as A, this point I am making as B, this point I am making as C. I would like to make it analysis on this. What analysis? We know it is a isometric length. Iso length I am writing. It is a true length. Now I would like to see what is the difference between iso length and true length. For that what I would like to do is, I am taking cos 30 degrees here in small triangle. These are all symmetrical triangles. I would like to find out what is the value of OB, isometric length, in terms of OA. I would like to find the relation between the true length and isometric length. I would like to find where OB is isometric length, OA is true length. So here what I would like to do is, I am taking cos 30, take cos 30 here. The cos 30 is equivalent to, what is this cos 30? In this triangle, the right angle triangle OCB, the cos 30 is equivalent to OC by OB we can write. OC by OB we can write. Then you can take cos 45 here. What is cos 45 in bigger triangle? OCA, OC by once again is OA. Now we do this analysis. You divide cos 30. Let us say this is one equation, second equation. I can do like this, 1 by 2, what happens? So it is cos 30 by cos 45. What we are getting? What is cos 30? We know it. Cos 30 is equivalent to root 3 by 2. We know it. Root 3 by 2. By cos 45. What is cos 45? 1 by root 2. Just simplify it. It goes root 2 times. So we can get root 3 by 2. We are getting root of 3 by 2 also in root. So at the same time, see about other side, it is root 3 by 2 we are getting, but what it is cos 30 by cos 45. Cos 30 by cos 45 is OC by OB by OC by OA. So what is this? OC gets cancelled. Here we are getting OA by OB. So OA by OB, see here, OA OB is equivalent to root of 3 by 2. So I wanted to have OB, then OB is equivalent to, I will do like this, OB is equivalent to root of 2 by 3 OA. Just see root of, just calculate it, we can get 0.817 OA. What is this? Here we know OB is the iso length, OA is original length. That means the iso length is equivalent to 0.817 times of true length. That we have to understand. They will ask what is the relation between isometric length and true length. That means when you are writing like this, we have to take, when you are writing these lines, actually you are supposed to take 817 times of the true length they are given. But of course, just observe it, I am not taken this. Actually, we have to take like this. So when we are taken this and when we are taken these angles like this kind of projection is called isometric projection. So here what I would like to tell here is two things I would like to tell. One is isometric projection, where the iso length is equivalent to 0.817 times of true length. Or for this, generally we are using like this. Sometimes we are using the word isometric view or isometric drawing. Please understand this. When the examiner is asking or otherwise somebody is asking isometric view or drawing, we are taking this angles, this side angle 30 degrees, this side angle 30 degrees, vertical only. But same thing we have to take it. When they are asking isometric projection, the lengths we have to take 0.817 times of true length. Here let us say they are asking isometric projection for 30 mm size cube. We have to take not exactly 30 mm, we have to take it. We have to have the value of 30 into 0.817 times of true length. That is what is the isometric length we are getting by multiplying this value, this factor. With that value only we have to draw it, but the angles are everything same. But second one, when we are coming to isometric view, all angles, all side angles 30 degrees, vertical only we have to take it. But we have to take exact length. Let us say I am asking about isometric view or drawing. We have to take with 30 mm only here in isometric view and isometric drawing. But only in isometric projection only the iso length is varying. That we have to remember. Next one, I would like to, one more important question generally they are asking is isometric scale. They are asking to draw isometric scale. What is isometric scale? Let us say your question will be like this. Draw the isometric scale. Draw the isometric scale for the length of 70 mm. So isometric scale, how you have to do it? You draw with a 2H pencil, very light pencil like this. This is O, let us say, anything. No representation related to OR, OB, which we are taken in this cube. Forget about that. Here I am taking O, A, something like that. Now, we have to have isometric length we want. Isometric length we want and true length we want. You take true length. True length is, we know it on 45 degree line. Draw the true length line by taking angle 45 degree. Put your compass over here. Take 45 degree. Let us say it is 45 degree. So here how much length we have to take? You know it. Because he is asking about 70 mm. Say measure 70 mm over here. It is 70 mm total length. Roughly I am taking it is 1, 10 mm, 20 mm, 30 mm, 40 mm, 50 mm, 60 mm, 70 mm. Right? Then we have to write iso length. It is true length. Actually, it is a true length. All you do with 2H pencil, because these are all called construction lines. But this is a measurable length. You take 70 mm, whatever, 100 mm, whatever it is. Here is asking 70 mm, I am taking 70 mm. It is a true length. Then isometric line we have to write it. Isometric line, how we have to write it? We know it. It is on 45 degree line. Take 30 degree line. True length on 45 degree line. Iso length on 30 degree line. Say 30 degree line with compass here itself from this point. We are getting this is 30 degree line. It is iso length. You just extend it. Now draw the perpendicular for this OA line. You keep your mini drafter here like my hand. From this, draft one more scale, from here draw it. Write it. This is the representation of 70 on isometric length. Whatever the length we are going to have it is 70. For this we have to take it. Write it. Please cut it, Amma. Please break it. Go. Okay, after drawing this 70, draw one more line, 30-degree line. It is called iso length. Here, we have to draw this line perpendicular to OA line to meet iso line here. Now, we have to draw different places for 10 mm, 20 mm, 30 mm, 40 mm, 50 mm, 60 mm like that, which is parallel to this line. It is also representing 70 on iso line. So, you take this line parallel to this, from here draw it. This is 60. Draw this parallel. How you can draw parallel? Keep your mini drafter here, make it tight, that what is called pivot. Keep here, parallel line. It is 50, it is 40, 30, 20, 10 like that. See here this is iso length, this is true length. Whatever the true length that is represented here, 70, this is 70 we are representing, but it is isometric scale. That is how we have to represent isometric scale. Draw this line with HB pencil, because this line only we want. This try to do other lines with 2H pencil. This is how we have to draw the isometric scale. Stop it.